How's it going, everyone? Eulier Gonzalez. That's right, here. Now, let's take a look at in today's video about the quick overview of what is the role of Node.js, and by understanding this, why we need to understand is how JavaScript works, and now what Node plays a role in accessing the internal computer features and how actually they do that, and also understand the mental models around this so we can know how that works and how now Node.js fits in our entire web development. So in today's video we're going to explore now the executing Node code. This is a course taught by Will Sentence, which is the CEO of Codesmiths, which is a bootcamp that allows software engineering machine learnings to understand now the fundamentals, not only from the technical side, but as well as the soft skill, which is something that is very important. Most CEO or leaders are there not because they are the most smartest one, but because they have people skills. And this is the reason why I'm doing this kind of recordings and taking notes out of this particular course, the hard part of notes, to understand, to explore, and to be able to describe that in the most succinct and effective way possible. So by understanding how do we get here, this narrative, and truly, not memorizing, but truly describe that, now it will not only make sense for you, but also to others junior developers, which is the reason why senior citizens, senior in any field, particularly in the computer science, are someone that are sought after. Why? Because now they can make all of this complexity meaningful to others. So they bring now that tremendous value to junior developers, mid-levels, or anyone who are at least curious about how to get into this particular industry. At the beginning is because they want money, which is, there is nothing wrong with that, but at some point you will realize that you will need, in any endeavor that you get in, all right, you will find out that you need more than that. You need more than that motivation. Money is important, but you will need something further to actually go after or to chase. But in any case, so the goal of this particular course is to now understand is how servers works, the nature of these communications between one computer and another, the client and the server, and how JavaScript works from the server to take control of the inner features of your computer. Okay, we're also going to explore is now streams, asynchronicity, something that I'm quite familiar, especially on asynchronicity, not for streams, and the anatomy of the node, which is the event loop, the callback queue, and the call stack. So first thing first, we look at the introduction, right? Which is how now Node.js fit into the entire web development, right? And understand asking a couple questions is what is a web application, okay? And starting from there. So well, after all, a web application is this now applications that use a browser to run and show you documents that are written in code, HTML for giving structure, CSS for predefined stuff, and the JavaScript to bring now interactivity to this document. So give you the ability, for example, to click on the document, something that you can do on a plain textbook, right? But this is something interesting here, because since this web application that is running on a browser, whether it is on the Linux, Mac, or any mobile devices, right? So for example, the Michael Max or Rich or Ceph phone, to now talk to another computer, aka to a server, okay, as a way to send a request or send a message or ask for a Twitter here. That message at sent over to the physical medium, it passed through something called as the OC model, which is allowed now these two different computers to communicate each other. This open standard interconnectivity, open system interconnectivity, okay, which is the OC model. And this is just like a pipeline of how it's going to transform your data into something that the network card can use and transmit or receive, right? So the pipeline works in one way or another, all right? So it has the application level where it transforms all of this format and prepare that from the presentation layer to indicate, hey, what will be the format in which where we're going to send this data into a JSON or to a TSD, all right? And then also prepare now the season. This is when now the port is choose. Which port are we gonna send this data, as well as the encryption. I think on the presentation is where the encryption happens. Okay, you have the application level, which is now communicate to the network services and pass that through the presentation to see, hey, how am I gonna send this data, and are we gonna send that encrypted or not? And then on the season is where everything is prepared to decide which port are gonna send this data. And then on the transport, it say which protocol, the set of rules to communicate, I'm going to use to actually transmit this data. It'll be connection based or connectionless, UDP or TCP, because we're going to use TCP. Then how now this data is going to be sent over? All right, what is the path that this data needs to be needs to go with? And that is the IP protocol. And here is defining is that particular path along the web. And then on the next one, which is the data frame, it say, hey, how am I going to send this message over the internet, over the cable? And this is known as the data frame. So this is divide this particular package in several small bundle bytes of package to actually transmit over, and then at the end recompose that. And then at the final level, which is the physical layer, is now when the data is transmitted, right? So you can think of this when you have now a flat house, it's connected, and once that water passed through the entire pipeline, now when you remove your finger, then it's sent over. So this is when this is the raw data is transmitted. So it passed through all of these different computers along the way, or physical devices, router, switches, and blah, 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 blah. And then it reached to the Twitter. So initially it reached to the DNS as a way to resolve first the IP address that it needs to send this particular message, aka request. and then it's sent back to the browser. The browser stores that locally for future requests, and now is then when it sends that to the proper server. So it passed through all of these different routers and physical switches and even computers, right? Until it reached to this destination. And by the time that it get that message here on the Twitter computer, right? Because this is something that is going to be received from the network card as raw binary. Yeah, the computer receives this raw binary, but it doesn't. It needs to be usable for the user, right? And that's why now the reverse pipeline of the OC model happened. So this is passed through the physical, the data frame, the network, the transport, the system, presentation, and now the application. So now this raw binary data is now in a format that you can now interact with it. This is powerful. This is interesting to understand this particular mechanism and be able to describe that. Now, because the way how can we have access to that information, okay, is with a language that allows to interact with internal computer features, whether it's PHP, Ruby, Python, Java, and JavaScript, because JavaScript is a powerful scripted language, but it doesn't have access to the internal features computer's internal features. So what language allow us to have access to? That's when you have now C and C++. So because of that, all right, and since from JavaScript, there are certain specific internal computer features that we want to have access, whether it is the network card, okay, the file system, because we also want us to store or read data from our computer or from other computers, okay. We want to also have the ability to now encrypt data for password encryption, that kind of stuff. And to have access now the input and output, or the kernel input and output. This is something that I am not quite familiar with, but when we talk about kernel input and output, we say is keyboard, mouse. Let me actually get into this. Kernel EIO subsystem. Okay. But kernel input and output. Kernel input and output. Kernel input and output. Okay, kernel input and output device. So for example, you want to have access to printers. Okay, so printers, keyboard, mouse, but there are also network adapters, okay, and display devices, but not limited to peripheral. Exactly, input and output device included, but they are not limited to keyboard, mouse, disk drive. Interesting. So input and output device are not limited, includes, but are not limited to whether it's the keyboard, the mouse, disk drive, printer, USB devices, network adapter, and display devices. Why am I mentioning this? Despite that it might be quite silly to do that. Well, because this kernel input and output is something that we need to use at some point as a way to now not only have access to the file system in the OS, but also is to, for example, read data from our disk or interact with the network card as well, or for any other peripheral, right? So because all of these features you can have access from JavaScript, but through C and C++, it allows to manipulate now this computer internal features. So the combination of all of this control, so you can think of the panel control, is known as Node. So in JavaScript, you can have access to these Node features that are exposed to JavaScript as labels that internally, through C++ code, it now interact with these internal computer features. So the idea here is to, by exploring Node, not to understand is how to write C and C++, is to look at the mental model, the inner mechanism of how the things works, and now from JavaScript, how that allows you to take control to those computer internal features. So because of that, we need to understand now how JavaScript works. So what is the role of JavaScript? What is the role of Node? In the what is the role? So what is the role of JavaScript? What is the role of Node, or how that Node.js works? And also is how the sending message or the HTTP protocol works. So first thing first, we explore is this stuff, which is, let me put it here. That's right. Which is what JavaScript does. It made three things, right? So it allows you to save and store data in its functionality to be used later on, and use that data by running functionality on that, or by running functionality on it, okay? And also allow you to have access to the platform-specific features, whether it's the browser or the Node. Now, we look at how can we describe this, at least these two first stuff that JavaScript does, to save and store data in its functionality, and then use that data by running that code. And first is describe this. Is also a good exercise to be able to describe what happens here when you want to analyze this silly line of code. But it's important to actually understand that, after all, the anatomy of JavaScript is that it has now a global execution, a function execution. You have now the threads, which allows to look similar like when you're reading a book, all right, go one line after the another, known as the thread of execution, and also the memory, where we can store now all of the data that we need to, whether it's primitive or objects, a memory in the features that allows to work with asynchronicity. That is the event loop, the callback queue, the micro test, and also the web API. But first thing first is this one. It's like here we are now storing is the number 3 on an identifier num in memory, right? So for example here, so on the left side we have is the thread of execution, and on the right side we have is the memory, right, or heap. So this thread of executions initially here is known as the global execution, and we're gonna explain that later on. And then the line 2 is now saying I'm going to now store this set of code into this label called multiply by 2, right? So we are going to bundle up the code that we don't need yet, and save it out and save it to run that later. Now line 3, which is here, on line 3 we're saying, hey, we're going to first evaluate this, so we're gonna call this identifier multiply by 2, and because it has now parentheses, okay, we are calling that, we are executing, so JavaScript is looking at that under memory, and if that has a reference to a function, it's going to now execute that. It's going to call that set of instruction, and by the time that happened, you're going to create now a function execution context. So because here we are passing now an argument, here we are injecting that manually, the argument num, where the value is now 3, okay. By the time we create this function execution context, which has its own, also we can explore this function execution context from no, but this is I want to look is at the specs, okay. The environment record type hierarchy, I think is this one. Yeah, exactly. The environment if I want to look, is the execution context. There you go. Executable code like this. Yes, that's right. Execution context. So this is all the execution context that exists. The code evaluation, which is using eval. The function, which is what we are doing, is evaluating the code of a function object, okay. If the context is evaluating the code of a script or model, the value is null. You also have something called realm, okay, which is the realm record, which is associated code access ECMAScript resource, realm record. That's quite interesting. Realms. It is evaluated. All JavaScript code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic object and ECMAScript global environment. Okay, and all of the ECMAScript code that is loaded with the scope of that global environment and other associated resources. Okay. The realm, exactly, that was the realm. Oh, it opened up a new one. Okay. Execution context. An additional state component for ECMAScript code execution context. So, but in any execution context, you have now the lexical environment used to resolve identifiers reference made by code within this execution context, the variable environment that holds binding created by variable with this execution context, and the private environment. So again, because we don't want to dive deep into this, just only mention the different type of execution context, even generators is now an execution context. All right, that's interesting. That's why we need to go back here to the roots to understand this way more. But this is a special type of execution context. So, interesting, very interesting. So with that, all right, by exploring that anytime that the multiply by 2 is, or in this case this function is called, and we know that it's called because it has parentheses, JavaScript detect that, all right, look at the identifier, and if that identifier exists on memory, good. Now it's going to call that function and then execute that, which in other words is going to now pass that to the call stack. But the call stack allows you to now keep track of where at which line of code you are currently evaluating. All right. Then it creates this function execution context where it's going to now evaluate the function body. But there is something interesting, because here we are manually passing is the parameter, okay, to this function, but something that something that will mention and say, hey, you know what? This is interesting because he says something. He say a tip, you know, about this mental model, and that is that Node is putting the value inside of our parentheses automatically. Instead of us having to do that manually, Node is putting those parameters, those values inside of our computer features automatically for us. And that's the entire paradigm of Node. It's interesting. It's this passing argument, but again, it's something that we're gonna see that later. But the thing here is that by the time we're now evaluating is this, where the result of this is whatever you get in the input times 2, which is 6, and then you're going to return the result. All right. Remember that after all, this function execution runs to completion. That's the characteristic of function. Okay, and then you now go, so you remove that, JavaScript removes that function from the call stack, and then now return that value that is going to be the value assigned to output identifier as a const. In other words, you can mutate or redeclare the value of this identifier. And similar here for the new output, but in this time we're passing is now 10. So again, a very silly example, but it's important to understand now what's going on behind the scenes, be able to describe each one of those steps and stuff, so we can now move to what we really care, and that is now executing the Node code.
Let's now see JavaScript's other talent, built-in labels.
and this is executing node code. Right, you say executing node code. All right. So let's see the other talent that JavaScript. Okay, let's see the other talent that JavaScript.
Let's now see JavaScript's other talent. Built-in labels that trigger node features. Because what are we trying to do, people? Our dream is to write JavaScript.
Come on, chill. I didn't do that.
Incoming message of the internet. Introspect.
I don't know what you are doing there. I didn't do that.
Did look into it, see what it featured. Let's now see JavaScript's other talent. Built-in labels that trigger node features.
Okay, so let's see the other talent. Let's see the other talent that JavaScript built-in trigger. Built-in. Let's see the other talent that JavaScript built-in. That JavaScript built-in enables a trigger no feature. Enables a trigger no features. No, not exclusively for Node, for platform. The platform that now JavaScript is run. Okay, because instead of, we're gonna see that later, but Node is a JavaScript runtime.
Because what are we trying to do, people? Our dream is to be able to write JavaScript code that can look at an incoming message off the internet, introspect it, look into it, see what it's asking for, and then send back the right tweets.
Okay, because what we want is to let JavaScript to access incoming messages from the internet introspect them, look into it, and then send a proper message.
That's our dream. So there better be a label from in here that accesses or sets up a Node C++ feature that can access the networking feature of our computer.
So it must be a feature, exactly. It must be a JavaScript label that allow us to communicate with the C++ feature to control network car in our computer. Exactly.
Oh, there better be one.
Okay, so it must be a JavaScript label that allows to communicate with C++ features to control networking features in our computer. It better be one.
Oh, there better be one.
Or a better one. Oh, there.
What is it? Well, actually, the main one's called net, but there's a more
The more general is net. Net from Node.js, bro, fellas. The net. Okay, so we can have access to the block list. And all of this representation using class from that. NetSocket, block list, net server, NetSocket. Create server, get default. Okay, is a okay, but this allows us to have access to that particular feature of this computer. IPC support. The model net support IPC with names pipe on Windows and Unix domain socket and operating system. Identifying path for IPC connections. Inter-process communication connection. Okay. Inter-process communicate. Okay, history. IPC support. The Node.net model provides an asynchronous network API for creating a stream-based TCP or IPC servers. Connection-based or internal service for internal communications. Okay, net create connection for internal communication. Useful, so TCP allows to communicate with other computers, and ECP allows to communicate with internal features. So for example, reading a disk on a database. So server listen, server socket connect, take a path parameter to identify IPC endpoints. So Unix, the local domain, is known as the Unix domain and all that kind of stuff. But again, this particular model, okay, allows or to provide, so give us access to these internal C++ features to control the network, the networking services, and allows to create is stream-based TCP or IPC servers. I am more quite familiar with TCP. TCP based stream. I am more quite familiar with this stream-based TCP rather than IPC servers. Rather than IPC servers. Okay. Exactly. Inter-process communication in Node.js that demonstrate both the server and the client, and I will include detailed comments on how to help you understand each part of this. Define the path for the IPC socket on Unix system, and this will create a socket file on Windows, and it will create a name pipe. Okay, define the path of the IPC socket. Okay, it will create now a file, socket file, or a name pipe. create the IPC server. You say, hey, I want to have access to these features to create now a server, client connect, and handle incoming data from client. Connection on, and if you receive a message type with greeting compute, you're gonna now reply to this. Connection write, JSON type resolve, and all that kind of stuff. And this is now handle this client disconnection, and this is handle the server errors. Socket is already in use. Start listening for connections. IPC server listening on socket path. Clean out the process termination. And the client GS, whether it's on net or path. Oh, on the client. Okay, it needs to take a look to determine what. Okay. Once it knows the socket path, all right, it creates now all of this internal properties to have access to this instance of the socket. To say this is connected, message queue, and that set up event handler, handle connection, handle errors, and we're just gonna send data. And this is on the connect and send the message. So you say, hey, I create now this new instance that is running that client connect message and set up event handler. Okay, and then I want to now send message to this. The example I demonstrate is the message passing between processes, error handling and recovering, clean shutdown procedures, cross-platform compatibility exactly with Windows and iOS, Windows and Linux, or Windows and DOS and Unix-like. Connection state management. You can extend this by adding more message type, implementing authentication, adding message acknowledgement, implementing bidirectional streaming. Adding timeout handler. But at least is to understand is this, because here is when it create now a Unix or a inter-process communication. So it create now this particular instance to communicate with another instance. The server and the client are different. Yeah, they're different instances, bro. On the CPU, on the OS, that are communicating each other. Yeah, that's exactly the key point about inter-process communication, is that the server and the client completely separated process running independently on the operating system. And the way they communicate here is via socket. Exactly. And the way they're communicating is via socket. All right. Okay. Okay. So you're. Okay. So this is net, bro. Okay. So net allow you to do that. Okay. Oh crap.
Specialized one called
Exactly. But there is a specialized one called HTTP, which is something that I'm quite familiar with in Node. Let me go to here. In fact, let me go here and say, hey, I want to look at the HTTP, HTTP2, HTTPS.
Node feature that's going to access the network card effectively and be able to receive messages in the HTTP format. And so we're going to see HTTP in more detail, but for now, just
a feature, exactly, a features from Node that allow us to control from JavaScript networking features to introspect communications, to introspect HTTP message.
No, it's a format by which you send messages or requests from a web browser, and whenever you type in a URL and press enter, you send out a message and it's sent out automatically in the HTTP format. Hypertext.
So when Rich computer, so when Rich from his computer type on the URL, right? So yeah, so when Rich from his computer type on the URL x.com to look up for tweets. Okay, so when Rich from his computer types on the URL x.com to look up for tweets, all right, to look up for tweets, it is automatically formatted that message into an HTTP, into the HTTP format, into an HTTP. So hypertext transfer, hypertext transfer protocol. Right, there you go. Hypertext transfer protocol. Let's say hypertext because is something that is not only static text. It also can allow you to describe is other type of content. You know, so for example, video and image. So how do you describe now a video on a plain textbook, right? If you can imagine how the people actually, so what the people, so the people at the CERN, because this was created by Tim Berners-Lee and Vincent Cerf, among other people that I barely remember his name, but sorry, I'm just learning on the road. Is this one?
Transfer protocol. Protocol means format of data and rules by how you communicate. Format of data, HT, hypertext. That's the structure of web pages linked between them. Transfer. It's transfer. Good. And we need to have our network open. We're going to discover we open a socket, which is
Hypertext is a way how
an
they.
open connection to the internet, an open channel to the internet, two-way open channel to the internet. We're going to discover that open connection, we need to have it formatted such that it's ready to receive HTTP formatted messages. How are we going to do that from JavaScript? Via what, Roman?
C++.
Not CSS. With C++. Exactly. There's powerful built-in node featureable HTTP, and it's associated built-in label in JavaScript. Everyone gets what I mean by label. It's a label, a word in here that will trigger something down here. That's what HTTP. Okay, here we go, people. Using HTTP feature of Node to set up an open socket connection to the internet. Socket's a posh word for an open channel for data to go in and out of a place over the internet. People, there's Macefield. Why are we going so deep? I want to build a cool-looking app. Folks, if we get this principle down, there's nothing else to Node. Today we're going to see all features of Node besides two. We may have time to do modularity. We may have time, and nothing else to Node. Today we're going to see all features of Node besides two. We may have time to do modularity. We may have time, and we may have we won't have time to do handling multiple threaded tasks. It's time to do modularity. We may have time, and we may have we won't have time to do handling multiple threaded tasks. In some way, handling multiple JavaScript instances. That's the one thing we're not going to touch. But otherwise, this model we're going to see will apply to every single Node feature that you ever encounter. All right, here we go. Using the HTTP.
This is something important because I am not quite familiar with this because this is part of the internal features about this thing.
Today we're going to see all features of Node besides two. We may have time to do modularity.
Okay. So we are going to look at two features to know in Node. One of the things is modularity. That's something I'm quite familiar with. And I learned the hard way. Modularity. Modularity. Okay.
We may have time, and we may have we won't have time to do handling multiple threaded.
Exactly, handling multiple threaded
tasks. In some way, handling multiple JavaScript instances.
Exactly, and that is handling multiple threads. And we will talk about threads because JavaScript is a single thread. Is like handling multiple JavaScript instance.
One thing we're not going to touch. But otherwise, this model we're going to see will apply to every single Node feature that you ever encounter. All right, here we go.
So this model applied to every single feature that we that you ever encounter. Every single feature that you ever encounter.
All right, here we go. Using the HTTP feature of Node to open a socket on the internet to the internet, such that when an inbound message comes in from the web, we can run code in JavaScript to send back a message to Sarah Rose's Mac. Okay, which comes in from the. All right, here we go. Using the HTTP feature of Node,
which is this one. So the example below is like this. Okay, so using built-in features like HTTP, okay, from Node to introspect,
to open a socket,
or in this case, exactly. So using built-in features from Node to open a socket here and introspect
on the internet, such that when an
okay, so using a built-in feature like HTTP from Node to open a socket from to the internet, exactly, to open a socket to the internet and introspect whenever message, whatever inbound message, and introspect whenever inbound message comes from the web, that comes from the web.
Inbound message comes in from the web, we can run code.
We can run JavaScript code to reply back or to send back a message. To send back a message to Sarah's Rose Mac, you know, to send that back, to send a message back to the client.
In JavaScript to send back a message to Sarah Rose's Mac. Okay, let's see how we use our built-in label up here. And I will say this, people, immediately, just so you're not confused. This built-in label, it needs to be http.createserver.
Give me a second here.